In this video, we're going to discuss when it's appropriate to do an ANCOVA, or some of the assumptions that need to be met. First of all, the covariate is related to the independent or to the dependent variable. In other words, if there's no relationship between the covariate and the dependent variable, as in axial length, baseline, and follow-up, then it wouldn't control for any variance. If there is more than one covariate, say you did axial length and sphere, then they cannot be related to each other. No multicollinearity. And finally, the third assumption is that the covariate is unrelated to the treatment variable. In other words, there is no treatment by covariate interaction. If there is an interaction, just include it in the model. Interpretation, however, becomes more complicated. So let's look at our data set. And our question is, if we go to graphs, is there a relationship between axial length and baseline, and are the groups parallel? So we'll just first look at this graphically. You can just do this with a simple graphical look. So here we get our scatter graph, and we can double click on that, go into editing mode, click on this little icon right here. It has the little dots around it and a couple of lines, and that will give us a line for each of the groups. Now, you might say, well, those lines aren't parallel because they're not exactly. Well, you know, this is life, and it's not always exactly parallel, but that's pretty darn close. I would say that you could say we have met the assumption close enough for analysis of variance on no relationship between the treatment groups and the covariate. That is, these lines are parallel. We can also say that there's a relationship between axial length and baseline because there's definitely a slope going up there. So we've met those two primary assumptions, and the other assumption was that multiple covariances are not correlated, and we don't have multiple covariates in this case. So we have met the assumption. Now, what would happen if instead of, and we just wanted to not look at lens, the spherical 5's I type, but we just wanted two groups, a spherical lens 5 curve and an aspheric 6 curve. So let's see what that would look like. We'll go to our scatter plot again, details, and instead of lens type 2, just lens type gives us the two types of lenses without splitting out the type of eye for the one lens. We set our markers by that. We hit OK, and we get the same kind of graph, although now we just have two colors, blue and green. Double click, go to our multiple that sets our lines by marker. Now there it's pretty clear we have not met the assumption of these lines being parallel. The other one, you know, they weren't exactly parallel, they were pretty close. This isn't close. And if we were going to do an analysis of covariance with that, then we would come in and we would alter our model, do a custom model, because the default is, well, it's calling this a full factorial. When there's a covariate, it just looks at the main effects with respect to the covariate. So we're going to come into custom. We're going to add the interaction between lens type and baseline. That gives us our interaction term, but we still need the main effects. So let's come here, lens type, ALL, ALO, and main effects. And now we're in there. And so let's run this. And now we see we have the lens type by axial length interaction. That was significant. Now, unfortunately, we don't just look and see that lens type is different. We have to kind of look at different points along the baseline and complete this regression equation in order to determine exactly where the lens types are different. And because if you'll recall from the scatter plot, in some points, particularly up here with the longer axial lengths at baseline, the blue and the yellow really overlap. There's no green. That's why the line is going this way when we combine them. And down here, we're heavily weighted. So up here, the lenses aren't different from each other. Down here, they are, except that they're not really for this subgroup. That's why we broke it into two different groups, because there's clearly two populations of eyes for the spherical 5-curve lens.